Hi everyone. Today we're going to study limits at infinity and horizontal asymptote. Let us study limits at infinity. If the values of f of x become arbitrarily close to L as x becomes sufficiently large, we say the function f has a limit at infinity and write limit of f of x as x approaches infinity equals capital L. Now, if the values of f of x becomes arbitrarily close to L for x less than 0, as absolute value of x becomes sufficiently large, we say that the function f has a limit at negative infinity and write limit of f of x as x approaches negative infinity equals capital L. If the values f of x are getting arbitrarily close to some finite value capital L as x approaches infinity or x approaches negative infinity, the graph of f approaches the line y equals capital L. In that case, the line y equals capital L is a horizontal asymptote of f. For example, consider the function f of x equals 2 plus 1 over x. Here is the graph. We can see here, as the values of x get larger, the values of f of x approach 2. We say the limit as x approaches infinity of f of x is 2 and write limit of f of x as x approaches infinity equals 2. Similarly, for x less than 0, as the values absolute value of x get larger, the values of f of x approaches 2. We say the limit as x approaches negative infinity of f of x is 2 and write limit of f of x as x approaches negative infinity equals 2. Now, the line y equals 2 is a horizontal asymptote of the function. Let's have now the formal definition of horizontal asymptote. If the limit of f of x as x approaches infinity equals capital L, or the limit of f of x as x approaches negative infinity equals capital L, we say that the line y equals capital L is a horizontal asymptote of f. Let us see this figure 1. We have the graph of f of x. As x approaches positive infinity, the values of f are getting arbitrarily close to capital L. The line y equals L is a horizontal asymptote of f. Let's have this figure 2. We have this graph of f of x. As x approaches negative infinity, the values of f are getting arbitrarily close to m. So the line y equals capital M is a horizontal asymptote of f. In this video, we're going to see 3 sample problems on how to determine limits at infinity and horizontal asymptote. Example: so for each of the following functions, determine the limits as x approaches infinity and x approaches negative infinity. Also, determine the horizontal asymptote. This is the first function. F of x equals 3x minus 1 all over 2x plus 5. Note here that the degree of the numerator and the denominator are the same. For our solution, we will take the limit of the function. So we write here the limit of 3x minus 1 all over 2x plus 5 as x approaches positive or negative infinity. As a rule, we're going to divide each term of the numerator and denominator by the highest power in the denominator. In this case, the highest power is x. So this expression becomes like this. Now, let us simplify each of the term. So the 3x over x now becomes 3 minus 1 over x will just be same. In the denominator, the 2x over x is 2 plus 5 over x has no change. Now let us take the limit of each of the terms in the numerator and in the denominator. So we will have this expression. Now let us simplify each of the limits. So the limit of the constant 3 as x approaches positive or negative infinity is simply 3 minus the limit of 1 over x as x approaches positive or negative infinity. This becomes 0 all over in the denominator the limit of the constant 2 as x approaches positive or negative infinity is simply 2 plus the limit of 5 over x as x approaches plus or minus infinity becomes 0. 3 minus 0 is 3 all over 2 plus 0 is 2. Simplifying this, we write 3 over 2. This is now the limit of the function. For the horizontal asymptote, we simply take this value and we write it here. So the horizontal asymptote is y equals 3 over 2. Now let us consider the graph of the function. Here it is. We can see that as x goes to positive infinity, the value of f of x comes closer and closer to 3 over 2. Also, when x goes to negative infinity, the graph comes close to the value 3 over 2 also. And the line y equals 3 over 2 is the horizontal asymptote. Let's go to function b. f of x equals 3x squared plus 2x all over 4x cubed minus 5x plus 7. Note that the degree of numerator is less than the degree of the denominator. For our solution, we're going to take the limit of this function as x approaches positive or negative infinity. Now, let us divide each term of the numerator and denominator by the highest power in the denominator. In this example, the highest power is x cubed. So this expression now becomes like this. Simplifying each of the terms, the 3x squared over x cubed now becomes 3 over x plus 2x over x cubed is now 2 over x squared. In the denominator, this 4x cubed over x cubed now becomes 4 minus 5x over x cubed is now 5 over x squared plus 7 over x cubed will just be same. Now, let us take the limit of each of the terms in the numerator and in the denominator. So it becomes like this. Let us simplify each of the limits. So the limit of 3 over x as x approaches plus or minus infinity becomes 0 plus the limit of 2 over x squared as x approaches plus or minus infinity is also 0 all over in the denominator the limit of the constant 4 as x approaches plus or minus infinity is simply the constant 4 itself minus the limit of 5 over x squared as x approaches plus or minus infinity becomes 0 plus the limit of 7 over x cubed as x approaches plus or minus infinity is also 0. Simplifying this, 0 plus 0 is 0 over 4 minus 0 plus 0 is 4. So 0 over 4 is simply 0. So the limit of the function as x approaches plus or minus infinity is 0. So for the horizontal asymptote, we will copy this value and we write y equals 0. This is the horizontal asymptote. Let us consider the graph of the function. We can see here that when x goes to positive infinity, it approaches the value 0. Also, when x approaches negative infinity, the graph comes closer and closer to 0. And we can see here now that the horizontal asymptote is the x-axis itself, and the equation is y equals 0. Let us have a quick look at these infinite limits at infinity. We say a function f has an infinite limit at infinity and write limit of f of x as x approaches infinity equals infinity. If f of x becomes arbitrarily large for x sufficiently large. We say a function has a negative infinite limit at infinity and write limit of f of x as x approaches infinity equals negative infinity if f of x is less than 0 and the absolute value of f of x becomes arbitrarily large for x sufficiently large. Similarly, we can define infinite limits as x approaches negative infinity. Let's go now to the third function. F of x equals 3x squared plus 4x all over x plus 2. Note here that the degree of numerator is greater than the degree of the denominator. For our solution, we're going to take the limit of this function as x approaches positive or negative infinity. We will divide each term of the numerator and denominator by the highest power in the denominator. In this case, the highest power is x. So this expression becomes like this. Let us simplify each term of the numerator and denominator. This 3x squared over x becomes 3x plus 4x over x is simply 4 all over x over x is 1 plus 2 over x is simply the same. Now let us take the limit of each of the term in the numerator and denominator respectively. And the expression becomes like this. Let us simplify each of the limits. The limit of 3x as x approaches plus or minus infinity, we write here 3 times plus or minus infinity. Then plus the limit of the constant 4 as x approaches plus or minus infinity is simply 4 all over the limit of the constant 1 as x approaches plus or minus infinity is simply 1 plus the limit of 2 over x as x approaches plus or minus infinity becomes 0. We can see that as x approaches plus or minus infinity, the denominator approaches 1. As x approaches infinity, the numerator approaches positive infinity. As x approaches negative infinity, the numerator approaches negative infinity. Therefore, considering one-sided limits, so we have the limit of this function as x approaches infinity equals infinity. Also, the limit of f of x as x approaches negative infinity equals negative infinity. So when we write the limit of f of x as x approaches plus or minus infinity, and we write does not exist. It means to say there is no horizontal asymptote also. Let us now consider the graph of the function. You see here, as x goes to positive infinity, the graph of the function goes larger and larger. Also, when the value of x approaches negative infinity, the graph goes to negative infinity also. And there is no horizontal asymptote in the graph. Today, we're going to study vertical asymptote of a graph. The line x equals a is a vertical asymptote of the graph of the function f of x if at least one of the following statements is true. This is the first statement. This is about the left-hand limit. So this is the limit of the function f of x as x approaches a from the left equals positive or negative infinity. The second statement is about right-hand limit. So we write the limit of the function f of x as x approaches a from the right equals plus or minus infinity. To emphasize, we write here, this notation is the limit as x approaches the value a from the left, or we say from lesser values. And this notation is the limit as x approaches a from the right. Let us see this example 1. For the following exercise, examine the graphs. We're going to see 3 graphs here. We will identify where the vertical asymptotes are located. This is graph number 1. It seems that the asymptote or the vertical asymptote is located in here. So the equation of the vertical asymptote is x equals 1. Graph number 2. Let us examine the graph. We can see that the vertical asymptotes will come in here and in here. So the vertical asymptotes are x equals negative 3 and x equals positive 2. These are the answers. Graph number 3. Examining the graph, we can see that asymptotes will come here and here. So we write x equals negative 1 and x equals positive 2. These are the answers. Let's have example 2. Find the vertical asymptote or asymptotes of the function f of x equals x cubed over 4 minus x squared. We know that vertical asymptote of the graph of the function f of x exists if at least one of the following statements is true, meaning the limit of the function must approach positive or negative infinity when x goes to a certain value a, either from the left side or from the right side. Considering the function here, this will approach positive infinity or negative infinity if the denominator becomes 0. So what we're going to do, we're going to equate the denominator to 0 and we will solve for x. So we write the denominator 4 minus x squared and this will be equals 0. Let us solve for x. The negative x squared we will transpose to the right. So it becomes positive x squared. Then we will take the square root of the left side and the right side. So we will have plus or minus square root of 4 equals the square root of x squared. The left side becomes plus or minus 2 equals x on the right side. So the value of x are positive 2 and negative 2. Therefore, For the vertical asymptotes, we write here x equals 2 and x equals negative 2. These are the answers. Now let us consider the graph of the function. See now that the vertical asymptotes will come here and here. So this line is the x equals 2, while the other is the x equals negative 2. I hope you learned something from this video. See you again next time.